All right, good morning, everybody. Today we're going to be doing lecture 16, function compositions. So let's go ahead and get started off with the notes. For those of you at home, go ahead and take out a sheet of paper, follow along with me. All right, suppose f is a function. And f is a function that's going to map x to y. X to y. Now right here, notice that x is the domain, y is the range, and f is just going to be a function. And we're going to say g is also a function. G is going to be mapping y to z. Notice here that y is the domain and z is going to be the range. So we're always mapping the domain to the range. Okay, so if we have both of those functions, then we can say g of f is the composition. G of f is going to be the composition of functions. F and g. And it's going to map x to z. Or in other words, g of f is going to be a new function that maps x to z. Okay, so that is our function composition. So just to draw you a picture on how this works, you're going to have a set x. We'll label this x, and x is going to be the domain. It's going to be the set of all x values. And then we're going to have a set y, which is the range. So I'll draw a set y. That's going to be the range of f. So we can say that f is going to be a function that's going to map every single x value to a y value. So I'm going to draw an arrow and put f on the top of that. So that's what f does. And then the function g comes in, and it's going to map y to z. So let me put g at the top, and we're going to have another set. This is going to be capital Z, and g is going to take y to z. So then if we have both of these functions, then we can skip y and go directly from x to z. So at the bottom, let's do an arrow that's going from x to z. This is going to be my composition, g of f. Okay? So this little dot that we have between the g and the f is always going to be an open dot. It's always going to be an open dot. And that's called the composition symbol. Okay, so what that means is if you have g of f, let's put that in parentheses, and we have an x off to the side, that's going to be my variable. That means that we can rewrite this as g of f of x. So notice for this, G is always going to be on the left side, while F is always going to be to the right of it. And what we're going to do is we're going to keep that same order when we go to the bottom part. G is going to be on the left side, and F is going to be on the right side. So what are we doing here? We're evaluating the function G at f of x. F is being evaluated at x, and then G of x is being evaluated at f of x. And that's called the composition of f and G. Okay? All right. And we can also have compositions that have more than two functions. So we're going to do that on the next slide. Okay. So let's imagine three different functions. We're going to have f. F is going to take a to b, where a is the domain and b is the range. We're also going to have a function g. What g is going to do is it's going to take b to c. B to c, where b is the domain and c is the range. And then you're going to have a third function, which is h. Let's call it h. H is going to take c to d. It's going to map c to d, where c is the domain and d is the range. So now we have three different functions that are all kind of linked to each other. So what we can do with these three functions is we can define the composition of three different functions. So the way I do that is I write h of g of f. So notice here I have three different functions. So I need two composition symbols, one between h and g and one between g and f. So I'm going to put all that in parentheses. And then I'm going to evaluate everything at the variable x. So I'm going to put the x in parentheses right there. So we're going to keep the order the same. Notice that the h is on the left side, so that comes first. Then the parentheses, and then the g is going to come next. So I put that after that. And then the last function is going to be f. And I'm going to evaluate that at the variable x. Now notice I have three different parentheses here, so I need to close all three of them. So 1, 2, 3. And that's my function composition. So notice what this function does. If I have a function h of g of f, that's going to start off with a, and we're going to map it to b, and then to c, and then to d. So this function is going to skip from a to d. Those are my two sets. A is going to be the domain, d is going to be the range, right? The set of all y values. Okay. So what we're doing here is we're taking the function f of x and we're putting it inside of g. But we're also taking the function g and we're putting it inside of h. So we have three different functions going on here. Okay, so if this is all true, then we can do what's called the associative law of composition. Associative. All right, so what does associative mean? This is only true if you have three or more functions, like I do on here. What the associative law says, it doesn't matter which order I group them. So I'll write grouping over here. Grouping. So it doesn't matter which order I group the functions. I could start off by putting G and F inside of a group. And that would be the same thing if I put H and G inside of a group. And then F is off to the right side, not inside of the group. And these two would be the same two functions. And that's what the associative law means. It doesn't matter which order that you group the functions together. Okay, and the last thing that I wanted to say about the notes was the commutative law. Does commutivity hold? So let me change my color to blue. And let's talk about ordering two functions. So let's say we had f and g. Is f of g the same thing as g of f? Can I switch that order around? Well, the answer is no. I can't do that. So function composition is not commutative. Function composition is not commutative. But it is associative. So it doesn't matter which order that you group two functions, but the order has to remain the same. Notice that the H is still on the left side for both of these. And then notice that G comes next. And then F comes last. So the order has to remain the same, but the way you group two functions is not going to change your answer. Okay, so those are the notes. Let's do a couple problems from the classwork. All right, so let's do number one together. We're given two different functions. We've got f of x. F of x is going to be equal to 4x. And we have g of x, which is going to be x squared. So these are two different functions. And what I want to do with both of these is I want to make a composition of those two. So what we're going to do is we're going to find g of f. We're going to find g of f, and we're going to evaluate it at x. So what does this mean? Well, we're going to keep the order the same. So g comes first. It's on the left side, so you know it's going to come first. So I've got g, and then f has to come after it. And then I put down the x. So notice what I'm doing. I'm taking the function g of x, and I'm evaluating it at f of x. So what I'm actually doing is I'm taking f, and I'm going to take that function, and I'm going to put it inside of g and see what happens. Okay, so the function g is going to stay the same, but f of x is 4x. So what I'm going to do is I'm going to replace this f of x with a 4x, since they're the same function, right? So now what I've got is I've got the function g of x, and I'm evaluating it at 4x. So that means everywhere I see an x where g is, I'm going to replace that with a 4x and see what I get. So I'm going to take that 4x, I'm going to put it inside parentheses, and then I'm going to square it on the outside. So why am I squaring it? It's because the exponent is 2 right here. So notice the exponent is 2. That means I have to square everything that's on the inside. So not only do I have to square the 4, but I also have to square the x. And when I do that, I get 4 squared, which is 16. And I have to square the x to get x squared. And I'm done. And that's my new function. So what I did there was I took the function f of x and I put it inside of g of x. Now in number 4, I'm actually going to change the order of it. I'm going to take g of x and I'm going to put that inside of f of x. But first, let's do number 2. Number 2 asked me to find g of f, which we just found, right? But instead of evaluating it at x, I'm going to evaluate it at positive 4. So what this means is I have to take the function that I just found and I have to replace the x on it with a 4. So what's that going to do? Well, I'm going to keep that 16x squared the same. But instead of an x, I'm going to replace that with a 4. So the 16 stays the same. The exponent of 2 is going to stay the same. The only thing that changes is the x, because I'm replacing that x with a 4. Okay, so let's see what happens when I do that. I get 16 times 4 squared. I know that 4 squared is going to be 16, right? So I'll just replace that with a 16. And then 16 times 16 is going to give me that 256 that I want. And that's my answer. So that time, notice that my answer was a number, right? And that's going to happen when you evaluate at a number like 4. But if you're evaluating at x, like we did for the first one, you're going to get a function instead of a number. And that makes sense, right? Because you're evaluating at x. You're not evaluating at a number like you are in number 2. Okay, so that's number 2. Let's go ahead and skip 3 and go on to number 4. Okay, so for number 4, the functions are going to stay the same. Your f of x is still going to be the same thing that I wrote at the top of the page, which would be 4x. And your g of x is still the same, right? X squared. But this time it asks you to find something different. It asks you to find f of g. F of g. So notice the composition symbol goes in the middle. I'm evaluating it at x. So I'm going to get a function for my answer. It's not going to be a number, right? So how can I rewrite this? Since the f goes first, I have to keep that first. And g is going to come after that. So I'm going to put g of x on the inside. Okay, so the f is going to stay the same. But we know that g of x is x squared. So inside the parentheses right here, I'm going to put in x squared. So all I've done so far is I've replaced g of x with x squared. So now what I have to do is I have to take the function f of x and I have to evaluate it at x squared. That means everywhere I see an x, I'm going to replace that x with an x squared. So I would have 4x, but instead of having 4x, I'm going to have 4x squared. And I'm done. That's my answer. 4x squared. Notice that's totally different from what you got in number 1, right? Because if we go back to number 1, we were trying to find g of f. That's 16x squared, right? But this time we've changed the order. Now we're finding f of g. And notice that's not the same as what we found in number 1. So order does matter when you're doing compositions. It's just that the grouping doesn't matter. All right, so let's do number 5 next. Number 5 says, take that same function that you found, that f of g, but you're going to evaluate it at a number. You're going to evaluate it at 5. So I'm going to take that 4x squared, and I'm going to replace that x with a 5 and see what happens. So I get 4 times 5 squared. We know that 5 squared is going to give you 5 times 5. That's 25. And now I have 4 times 25, which is 100. That's going to be my answer for number 5, 100. So if you evaluate at a number, you should get a number for your answer. Okay, let's do number 7 together. Okay, so for 7, it gives us the same 2 functions, 4x and g of x, which is x squared. But this time the question is totally different. It's asking us to find f of f. So we need to find f of x, but evaluate it at f. So how can I rewrite this? I'm going to take the function on the left side. That's an f. I'm going to keep that first. And then I'm going to take the next f and I'm going to put that on the inside and evaluate that at x. So now notice I have 2 functions f. So it's kind of like I'm taking a function and putting it inside of itself, if that makes any sense. I'm going to keep the first f the same, but on the inside of the parentheses, I'm going to replace this f of x with a 4x. Because I know that f of x is equal to 4x up here. So those two are the same thing. I can just replace that with a 4x. So now I need to figure out what f of 4x is. So I'm going to take this function and I'm going to replace x with a 4x. I get 4 times 4x, and that's going to give me 16x. All I had to do there was multiply 4 by 4 to get 16. And that's my function. 9 is kind of the same, except I have g of g. And the next one I wanted to do was number 11. So let's do number 11 together. Now for 11, I'm given three different functions. It tells me f of x is going to be 2x minus 3. It tells me g of x is equal to x squared. And it tells me h of x is x minus 9. So for this question, it wants me to find h of g of f. H of g of f. And I'm going to evaluate it at x. So how can I rewrite this? Well, I'm going to keep the order the same. So the h is going to come first, then the g, then the f. And then x is going to go inside the parentheses. Okay, so we're going to go in order from inside out. I'm going to keep h and g the same. Now I know that f of x is equal to 2x minus 3. So I'm going to put 2x minus 3 on the inside. So now what I'm doing is I'm evaluating g of x at 2x minus 3. My h is going to stay the same. On the inside of that, though, I'm going to be squaring 2x minus 3. So I'm going to have 2x minus 3 squared on the inside. And that's because g of x is equal to x squared. So I'm literally just replacing the x with the 2x minus 3. So what's going to happen there? I'm going to have 2x minus 3 squared. I can rewrite that as 2x minus 3 times 2x minus 3. So here I can do the FOIL method. I multiply 2x by 2x to get 4x squared. I multiply 2x by negative 3 to get minus 6x. On the inside, I'm also going to have a negative 6x. And then negative 3 times negative 3 is going to give me a positive 9. And then I close that up. Okay, so now I've got my h. And on the inside, what do I have? I have 4x squared minus 12x plus 9. So I'm going to put that on the next slide. I'm going to have h of 4x squared minus 12x plus 9. Okay, so what was the function h in the first place? Well, remember that h of x is equal to x minus 9. So what I'm going to do is I'm going to replace the x right here with whatever I have on the inside. So I'm going to get 4x squared minus 12x plus 9. But then on the outside, notice I'm going to have a minus 9. And that comes from right here, this function h of x. So now what's the last thing that happens? I'm going to have a positive 9 minus 9. So they're going to cancel each other out. And I'm left with 4x squared minus 12x. And that's my answer. So if you're composing 3 or more functions together, it's going to take a little bit more time, but you should still get a function for your answer. because you're evaluating at x. But for the next question, you're evaluating at 2. So you should get a number for your answer for the next one. Okay, so that was number 11. The last one that we're going to do together is going to be number 16. So let's try number 16 together. Okay, so 16 is going to give us 2 different functions. I have f of x is equal to the square root of x minus 5. And I've got g of x is equal to x squared plus 5. And it says find the domain of what? G of f evaluated at x. So let's figure out what this composition is going to be. Now, if we take g of f, we can rewrite that as g of f of x. Notice that the g comes first because it's on the left side. And then f is going to come next because it's on the right side. Now, what is f of x? That's going to be square root of x minus 5. So I put that function on the inside of the parentheses, right? And now what I'm going to do is I'm going to take g of x and I'm going to replace every single x with that square root of x minus 5. What that's going to give me is that function squared plus 5 at the end, because I'm using this function right here. All I did was I replaced x with the square root of x minus 5. That's all that I did. So what happens here? The square root and the exponent of 2 are going to cancel each other out. So I'm just left with x minus 5. But then that plus 5 on the outside is actually going to cancel out the minus 5 on the inside. And I'm left with just an x. So x is going to be my new function. But it says find the domain. The domain is a set of all x values. So which x values can I put inside this function? Well, you would have to start off with f of x, right? So what's the domain of f of x? What is the domain of f of x? Well, which x values can we put in for x? The only x values that we can put in are going to be numbers that are greater than or equal to 5. So x is going to be greater than or equal to 5. So why is that? It's because the number under the square root can't be negative. So I can't have any negative numbers under the square root. So x has to be at least 5 for this to work. And that's going to be my domain. So just keep in mind that domain is a set of all x values. Look at the first function that you're evaluating at, and that's going to give you your answer. Okay? All right, I think that's all I'm going to cover today. If you guys have any questions, go ahead and put them in the chat box. There are going to be 2 assignments that are going to be due by Sunday. So let's talk about them. There's going to be the compositions classwork. You can do that today. And then later on this week, we're going to talk about the inverses classwork. And we'll do that on Wednesday. Okay? If you got that and you don't have any questions, you're free to go. Class dismissed. If you have any questions about this lecture, though, or any questions on the homework, go ahead and put those in the chat box, and I'll get to you very soon. Have an awesome day.